We investigated problem C regarding the dog who had a problem catching food. To describe this problem, we used equations that describe projectile motion, taking air resistance into consideration. The first set of equations describes the x and y components of the initial velocity. The second set describes the total velocities at different points in the projectile path. The third set are ordinary differential equations that describe how the position of the object changes as a function of time, also known as the velocity, in both the x and y direction. The fourth equation describes the force of drag acting on the object due to air resistance. The last set are ordinary differential equations that describe how the velocity in the x and y direction changes as a function of time, also known as the acceleration of the object. We use these equations to illustrate the path of the projectile and how it was affected when we changed the type of food thrown to the dog and the height that it was thrown at. In order to formulate these equations, we needed to make some assumptions and estimations. To use these equations, we need to assume that the food is a rigid body, which means that the food is not deformed during its motion. We assumed that the food was not spinning. We also estimated that the height where the food was released from the owner's hand was the same height as the dog's mouth, so that the initial Y position was equal to the final Y position. Finally, we assumed that air resistance has a significant impact on the food's motion. We chose 4 specific foods that were thrown in the videos to analyze drag, which each had a different shape: the meatball, the donut, the taco, and the strawberry. Through research, we found the coefficients of drag, radius, and mass of these foods to use as estimates. We assumed that he threw the food at an angle of 80 degrees with respect to the ground and used the constants for density of air and acceleration due to gravity. In order to find the time that Fritz had to orient his head, we slowed down the videos and calculated the time that it took for the food item to get from the hand to his mouth. However, these estimates aren't comparable because the initial velocity and launch angles were most likely different for each throw, which would result in different times regardless of the food. For this reason, it is more realistic to compare the difficulty while decreasing confounding variables. We did this through our models by changing the variable of interest while keeping other variables constant. This way, it was obvious which variables are having each effect. The difficulty of this task is dependent on several key components associated with projectile motion: the launch angle, the initial velocity, time that the dog has to react, acceleration of food, velocities, horizontal distance that the food travels, and the max height are all variables that can affect the dog's ability to catch food. We created a MATLAB code to model the change in projectile motion with differing maximum heights. To solve the ODEs, we use the ODE 45 built-in solver, which uses the RK4 methods to solve for these ODEs. To determine the effect that the maximum height has on the difficulty, we created a graph to demonstrate the projectile motion while varying the initial velocity in order to provide differing maximum heights. The characteristics of the meatball were used in order to keep the drag force constant. From the graph, you can see that if the maximum height is varied, it would affect the distance that the food travels, which could increase the difficulty. If the food's final horizontal position is far from Fritz, he would have to move his body along with orienting his head correctly, which adds additional opportunity for error. The graph also shows that throws with different maximum heights have different flight times. This could also increase the difficulty of the task because it would impact how much time the dog has to react and get his mouth and body in the correct position.
As stated, we focused on 4 different foods, and now we're going to show how difficult it is for Fritz to catch food in his mouth while factoring in air friction. The faster velocity, the harder it will be to catch. Regarding air friction, larger objects tend to have less air resistance, which is why they fall faster. While in a vacuum with no air friction, all the food would fall at the same rate. But because Fritz is outside, we must take air resistance into account. Air resistance is dependent upon the drag coefficient for objects, which is strongly dependent upon the object's shape. Here is a graph that demonstrates the projectile motion of the different foods with air friction being accounted for. The taco, as shown, does not go as high as it has a larger mass and thus has less air resistance, which is why it comes down faster. The strawberry goes higher and has a larger projectile motion, and while it has a lower drag coefficient, the shape and the mass of the objects allows it to be in the air for a longer time. Here's the MATLAB code we used to find the graph. We define the food properties for the meatball, donut, taco, and strawberry. Then we used the ODE solver, calculated the drag force, and then included the equations of motion.
For this specific experiment featuring the ability of Fritz to catch the specific food, it was important to take into account the many different variables that were contributed into the success of Fritz catching the food. These variables were primarily the launch angle, max height, horizontal distance, the time, and the initial velocity. Changing these variables, especially changing the initial velocity, severely decreased Fritz's ability to catch the food. Also, while there were many outside variables contributing to the success of Fritz's ability to catch the food, his own dog behaviors had to be taken into account as well. Fritz's own depth perception, ability to smell, and the fear level were all factors. Fritz is not necessarily being exploited, as these videos are just for entertainment purposes. They are not made to make Fritz look bad. However, if more videos are needed to be produced, the enjoyment behind them is watching Fritz miss the food. To ensure that it is harder for him to catch the food in his mouth, the food should be thrown up faster as it is harder for him to catch it, and it travels faster. Additionally, the heavier and the larger the food, the less height it will reach if thrown at a constant launch angle and velocity. This will lead to Fritz to have less time to react and catch it, making him look worse. For future improvements of this experiment, it would be best to take into account all of the variables being used, such as vertical height, horizontal distance, time, and position. These were all estimated values, and to improve the accuracy of the experiment, it would be best to have a better visual representation of this data. With this improved visual representation, our MATLAB group could also be able to input an input function. The input function would allow us to promote the user for an input and store the entered value as a variable. Thank you.